Set it off. Here we go. Do it. Like. Turn the lights down, 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 down.
Welcome to the Spectra Ocean Dream Circuit. Racers, start your engines.
Hello. Switch the mic.
You good?
Space on my part to think I can't feel it by myself. Need inspiration by myself. Space on my part to think I can't feel it by myself. 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 Can't feel it by myself.
Yeah, and well, usually the answer's no in those things, isn't it?
Yeah, no, it's no.
When the media leads with a title like
Yeah,
that,
it's always no.
no.
Hey everyone, so we're starting with the open sessions now, or is it Rob's talk and then? Rob.
I'm an open session, I think. Yeah.
Okay. Cool.
Ready? Not yet. All right. Hello, is it me? Hello. I wasn't going to do any kind of talk, but then it was as people have presented things and talked that, like, this is a thing that I have just thought about in the past, is like, does the internet work in space? And this is especially inspired by a TV show / book series called The Expanse, which I think is the best sci-fi we have had in recent decades. I could go off on a whole thing about, the differences between, Star Trek and The Expanse and why The Expanse is so much better. And it's basically because there's much less hand-waving in The Expanse. There's a lot of science that actually kind of works. But this is not what this is about. This is just thinking about the internet, because I think the whole point of this open space conference is to think about how do we do it in an open way. And I think that's my fear about the internet in space, is like, if we don't do it in an open way, maybe it won't be as good. Next slide, please. So yes, I am not an expert. I am just literally a bit of a nerd that likes sci-fi. I usually work in UX design and I love immersive tech, but I'm not an expert in this. So people will probably correct me on a lot of the things I'm about to say. Literally just my musings. Next slide, please. So this is The Expanse, if you haven't seen it. Set in the not too distant future, a crew of people going around the solar system and beyond, on a spaceship that sits vertically like a skyscraper that can go in continuous thrust at 1G. Let's not worry about how they do that, but go continuous thrust so you can walk around on the spaceship without the need for hand-wavy artificial gravity. That's one of the cool things about The Expanse. There's many cool things about The Expanse. But that's The Expanse. Next slide, please. How does the internet currently work on Earth? Sorry, I forget your name, but you talked about undersea cables, which made me throw in this next slide, which is maps of undersea cables in the Earth. And we have these cables that run under the sea everywhere. Lots of our internet traffic goes through them. But essentially, it's a fixed infrastructure where we have all of these servers, content delivery networks. Those are the things that Netflix got really good at. That's why Netflix is that bit faster than a lot of other streaming services, because they have servers all over the place that have the content physically closer to you, and that physical closeness means that they can shave microseconds off the amount of time it takes you to get your content to you. The internet works in lots of different ways, but I think this is the important bit in the context of this talk, is all of these nodes, content delivery networks across the Earth, with all of these undersea cables that are carrying the signals. And in the context of the Earth, in the kind of the relative size of the Earth compared to the speed of light, we can get signals around the Earth almost instantaneously, because the Earth is, in terms of the universe, is relatively small. Next slide, please. So then I started thinking about, how does communication with Mars work? We have robots on Mars and they send stuff back to us. I think the minimum time it ever gets to, because of the distance between Earth and Mars, is about 7 minutes. So there's this 7 minutes of hell thing that happens when they're landing a rover on Mars, where it's already crashed by the time they start hearing of its descent. They don't know if it's worked until they get that final signal. And I watched the last one when Perseverance landed with my kids, and there was this moment where they get the signal to say, Perseverance has landed, like, what is it? Touchdown confirmed, that's what they get. And the whole mission control goes crazy. And it was really, really wonderful. But essentially, kind of how it works is, we've got Mars, and there's a satellite out above Mars that orbits, and that communicates with the robots on the surface. If you've not heard the joke, Mars is the only planet in our solar system entirely populated by robots. That's cool, isn't it? We put them there. So those robots send up a signal to the satellite, which then sends signals to another satellite around Earth, and then the signals come back down, which seems fairly reasonable. It's a long way, and as I said, that time lag can be like 7 minutes. But, next slide please, there's a problem with this. Things can get in the way of that signal, like the sun. The sun could be in the way of that signal, and then all of a sudden, we have no communication, because we don't have that fixed infrastructure. We don't have that network of, next slide please, nodes. And this is what would need to happen in space. We would need to have these nodes flying around all over the place at Lagrange points. That's the distance between two bodies where the gravity kind of cancels each other out. We would need all these nodes to transmit the information. How would they work? Don't know. They're a bit kind of, I think, like content delivery networks. But at the same time, Netflix isn't going to put all of its own nodes out there. If, say tomorrow, there sprung up a population of people on Mars that wanted Netflix, and Netflix thought they could make money from it, how would Netflix do it? Well, I think them putting all of their own CDNs in space, I don't think that really would work. Next slide. What have I got next? So yeah, there's lots of challenges with it. The distance, packet loss, like because it's all done wirelessly, it's so prone to interference, that signal, you're going to lose packets. Low embeddable payload was a thing I read on Wikipedia, which is just that satellites can't carry and transmit lots of data because of the energy implications that they need to do that, especially with the lightness of things you need to put up in space. That lack of nodes, and again, there's no fixed infrastructure. In the Earth, all of these nodes stay where they are, they're reliable. But if you need to communicate with Earth, you're going to have to constantly be changing which route that you're taking to get this data. That's why it causes big problems when somebody goes and cuts an undersea cable. They don't just swim down there, they use trawlers, don't they? But if an undersea cable gets damaged, it causes huge problems because our fixed infrastructure breaks. In space, we can't rely on that fixed infrastructure at all. Next slide, please. So, just some ideas from The Expanse that I think are cool and influence the way that I think about how we might do the internet in space. So what's the first bit I put down? Is it hand terminals? Keep going, next slide please. Oh yeah, here's The Expanse again, keep going. Smartphones versus hand terminals. So in The Expanse, they have an analog for smartphones. Next slide please. It's these, the hand terminals. They look way cooler. Everybody knows glass displays, holographic displays don't really work, but they don't really describe them in the books, which is actually a good thing. But in the TV show, they have all these kind of augmented reality pop-up hand terminal things. I think it's, I forgot the name of the book, but one of the books, there's a specific line where one of the characters, Amos Burton, I think he's in the next slide. Yeah, this guy, he is the guy, he is that guy. He loses terminals so they can give them out to people. So they're still a really critical piece of, personal computing, but at the same time, they're kind of not the be-all and end-all. They have some processing power, but they're really connecting to local services on asteroids and on space stations and on planets. And I think there's even talk in the books of a partition, where it's like you go and you have your partition on Ganymede or wherever it is, and that's where you get all your data from. And maybe that authenticates with, I don't know, your banks and other things like that. Let's put that to one side. Next slide. Yes, so the cloud versus partitions. I think these are a lot closer to what kind of currently happens. And now the cloud, it's just other people's computers, it's other servers, but it's a way that we can get access to the same data everywhere and maintain that synchronicity across any device that we use. And I think partitions is a way to think about it. Actually, a really more interesting way to think about it, next slide please. There's this bit here that kind of shows what they mean, where if you go on to the next bit, they have like an authorized user thing. It's like the hand terminal has been authorized to a specific user. I don't know what that means, it's just graphics from the show. Next slide. But the Solid project, anybody heard of the Solid project? So yeah, so Tim Berners-Lee, I actually did get to work on a project on a Solid instance as part of some BBC R&D work. But it's this specification that allows people to store their data in decentralized data stores called pods. And then you control, or whatever the entity is that owns the pod, controls who has access to the data. This is a way of thinking about personal data that's like kind of flips it on its head at the moment. Right now, I give all my personal data to Amazon and Google and Meta and every other company. Every single time is like, give me all of your data and I will hold it and I will harvest it and I will analyze it and keep it forever in a huge lake of data. This thinks about it in the other way. It's like, what if I have the canonical me, the data that is mine, and when Amazon want my data, I go, okay, you can have access to my pod, you can have access to these bits of my pod, just the bits you need, and then if I don't need you to have access to my data anymore, I can take it off you and you don't have it anymore. And it uses all of these standard open and interoperable data formats and protocols. That's kind of how I think it will be better to make it work. It's like if we started a new internet on Mars, we would all have our own pod, our own personal data store. It's almost like your kind of national insurance number, national identity. When you're born, this is your personal data store that you use. Who controls it, how it should be all decentralized and whatever, but let's gloss over that. But that's how it should be. So then when we have the internet, the MarsNet, whatever it is, it works that way instead of organizations having to hold on to all of our data. Next slide, please. On-demand versus feeds. I stopped working at the BBC 4 weeks ago, so I'm aware of the legacy of broadcast television and how that seems to keep going, even in this age of on-demand. But in The Expanse, they have feeds. I think I got a picture. Yeah, there's these two screenshots of feeds when, spoiler alert, asteroids hit Earth. I've just ruined The Expanse for you. It's all right. It doesn't destroy Earth. Spoil us more. But there's this scene where the crew of the Rocinante are on a ship, and there's a screen in the kitchen area, and one of the characters, I think it's Amos Burton, is pouring coffee, and he just looks up, and he sees that this has happened on Earth, and it's obviously shocking news that this has happened. And he pours coffee everywhere because he's so shocked by it. But the point is, when you've got that distance and that time delay, you can't, like, getting the news now could potentially be a slow thing. If I'm waiting for the push notification to come from Earth, that's going to come to me eventually, but to get all of the up-to-date information, I can't really. It's harder to have, like, a live conversation with a server on Earth. You've got to back up. It gets a bit weird and wonky, I think. And so live broadcasts, especially if you're floating in the expanse of space and you don't have access to, you know, a data stream that's coming directly from Earth, sorry, as in like an internet stream, having just a broadcast like radio or TV that goes out there is just much easier to deal with. So you getting a broadcast and being able to get the most live update on what's going on, 24-hour rolling news, as much as hours mean anything in space, becomes a thing again. I don't think broadcast television and broadcast radio completely dies. There's even, I think in the role-playing game, I was just reading about this, there is an organization that sits at the Sun-Earth Lagrange point and manages all these feeds and takes them and then rebroadcasts them out into the solar system so that people can access them. Next slide, please. Just random thoughts. Yes, we could lift and shift. We could do like CDNs in space. I don't know, I'm glossing over it a bit. We could lift and shift it. But I think we could also fix what makes the internet shit. Like the things about personal data. Like we can actually kind of try and do it again. We can have a local internet on a planet. And yes, we're going to have like syncing happening between Earth and Mars. But do we really, really want the internet as it is to just make its way to other planets? I don't know. Yeah, the re-emergence of live TV channels. And then I've just called this thing the capitalist gold rush, which is a bit of a provocative statement. But I just think we've got an opportunity, hopefully, to kind of do that thing where we do a nice standard decentralized open thing when we get somewhere, rather than Elon Musk getting there first and putting Starlink in and making everybody dependent on Starlink. Is there a way we can do it that's a bit less capitalist, a bit more open? Those are all my random thoughts that I just had today. Thanks very much. That's it. Does anyone have questions? Oh, God. And you missed the disclaimer. You left the room that said, I'm not an expert. I'm just making things up. Yeah. Go for it.
Do you want to go first?
Do you want to go first?
Well, yeah, mine is, have you thought about the licensing, TV licensing or something?
TV licensing in space.
The space license.
I mean, you don't need it for the radio. But yeah, I mean, now let's not talk about the TV license. I have many thoughts. I'm only 4 weeks out of the BBC, so it's still a bit raw. Sorry, what were you going to say?
So I've got loads based on various slides, so I don't know if you want to go back to those.
Oh, what?
Well,
Okay.
if you stick on this one for now. So you're talking about what makes the internet shit. So you're talking about like kind of TCP style, you know, response, request response stuff. But we have UDP, so UDP exists for broadcasting.
Right.
On the internet. So isn't that wouldn't that solve it?
I don't know. I don't know enough to be able to say yes or no.
So essentially UDP packets, you broadcast them out, you don't expect any response from anyone.
Okay.
It's actually a broadcast style protocol.
Mhm.
So that exists for like live streams on the internet. Like kind of
But I guess is it the most efficient way? I don't know. That's a whole other conversation, I think, isn't it?
I don't know about efficient, but it kind of solves that problem of you want to broadcast something and not care about who receives it,
Yeah.
or if they miss stuff. Like so, it's like a feed almost
Right.
going out. So I think that already kind of exists. Whether it,
Yeah, you just need that infrastructure problem solved.
well, yeah, I was going to
Yeah.
talk about that separately.
Oh yeah, what were you going to say?
So the stuff like the Lunar Gateway and things like that, is that an attempt to solve?
I don't know what's the Lunar Gateway.
So the Lunar Gateway, so that's a NASA project, obviously way far off, but the idea of having a kind of base that collects information and resources, like kind of near, like in between Earth and Moon.
Right.
And then if that's in the right position, then you kind of avoid that whole like Mars being behind the sun, because there should be enough distance to get around the sun to see other things.
Yeah, yeah.
So I don't know if the Lunar Gateway solves that problem, but you can Google it. Lunar
I
Gateway,
will.
So.
I will. Sorry, you had a question.
I was just going to ask what your name is.
Oh, my name's Rob.
Okay,
Rob Scott.
What's your surname?
Scott.
Scott.
Rob Scott. That's
Love
it.
to chat to you because we want to build the internet of space.
What?
That's what
Ah,
our business is trying to do.
Brilliant.
You're talking about distributed systems. We're looking at blockchains for that, especially
Yeah.
with the
access to data. You can do lots of interesting stuff with zero knowledge proof.
Yeah. Yes.
Credentials.
Exactly. Like that stuff on like identity. Like I shouldn't need to tell you my name
Yeah.
to be able to prove that I am who I say I am.
Yeah.
Just give me the service and
Yeah.
trust. Yeah.
Or just give me yes or no statements about
Yeah.
whether something is true, and I'll
Yeah.
confirm that. With,
Is this a human? Yep. He can have my service.
yeah.
Yeah.
So we're in business to try and do that, and
Cool.
we've got interest. But I think I need you to come and help us.
Oh really?
Yeah.
Sure. I'll do that. As I've said, I'm recently freelance. So yeah, let's talk. Do you have a question?
What's the Lagrange?
Lagrange. I think it's a point between two bodies where the gravity of the two bodies cancels each other out. So therefore you can kind of maintain a kind of that single position between those two bodies.
Yeah, it's like an equilibrium with it's hard to explain, but
Yeah.
it's like a gravity well where you just stay in the same kind of
Like orbital status.
It's a bit like geosynchronous orbit, but between two bodies.
Yeah.
Yeah, and so therefore it's not halfway because it depends on the mass of the two
I'm
objects.
thinking of it in a 2D way, but it's
Yeah.
3D now, so that's
And like it means you have to, and I think it means you have to use minimal like
mind you,
like
it's all on a plane, isn't it?
inertia correction to stay in that point. If you get to that point, you shouldn't have to do too much correction to stay there. Whereas if you're out of that point and you want to stay where you are, it will be much harder to stay where you are in relation to things because you're not at that point.
It's like if you imagine like holding a broom, then you go on, the planet is the broom facing down, so it's super easy to stay stable. You flip it up and balance it, that's the Lagrange point. I've got a question there.
Oh right.
I've got more.
Ugh.
What was I going to ask? So, Axiom, built by it's a company built by the guy who built the space station.
Right.
They've just signed a memorandum of understanding with Manchester to build orbital data centres here.
Oh really?
Well, to send up.
That's cool.
Or do some of the services, so like we're already like
Oh, right, yeah.
we're already in the mix.
You should all watch The Expanse. I'll read it.
Even though you've ruined it.
Even though I've ruined it. Well, and I would say try the books first because they do that thing in TV where they merge characters together, and I kind of flipped between the two, and I had to like peel characters apart while I was reading the books, which was a challenge.
You know that Stephen Strait was at ESA Open Day last year.
Oh really?
Yeah, had a bit of a nerd session.
Nice. Right.
God,
Well, good.
unbelievable.
Thank you very much. I'm going to go in a bit, but hang on to my microphones and I'll pick them up tomorrow.
How close does it need to
So
be?
you can pick it up now. So you're standing in the middle of these two guys here, and you'll be on camera there.
Okay.
Yeah, give me your best shot. It's alright, no, it's all on the screen. I'll take this off. You can get started, mate. I'll do this in my job.
Yeah, so this is a bit of a quick discussion point I came up with kind of on the spot earlier with a bit of heavy pressure from Cash. So yeah, I'm expecting a bit of back and forth between you all. So when we think of space travel, most of us probably start by thinking of ourselves either floating around in space or perhaps strapped to the rocket waiting to launch, or maybe walking to the rocket in slow motion with the helmet under your arm. But what happens before then, between you deciding when you want to go and it actually happening? Well, at the moment you either get a space agency to hire you and train you up and all of that, and you have to sign a lot of legal waivers and all that. Or you can go private space travel, in which case you have to have Jeff Bezos or Elon Musk to hire you and train you up, and you've still got to sign a whole load of legal waivers and all of that. So, what might it look like in future is the point. So, and how would we get from where we are now to that? How would we end up with a process more like a plane where you just book a ticket, you go to a spaceport, you have a passport, you get patted down by security, or even you don't even have to bother with security. You have something a bit more like a train where you just buy the ticket and you get on, and that's it. So I guess that's the point of the discussion I'm trying to create here is how do we go from where we are now?
Space.
Sorry?
Border control for space.
Exactly, yeah, like the train line of space,
Everything in between.
pretty much.
Interesting.
Space license, like a driving license.
Possibly, yeah. You could have your own rocket and everything.
Could extend like pilot's licensing for astronautics. So, like,
Yeah.
an astronaut license.
And then you have like maybe like a minimum number like of hours to fly when you fly land, fly plane. You have to keep up your minimum number of hours, I think.
Yeah.
Well-
So like a minimum amount of training that you would need to do in that to keep your space license to allow you to just book on a flight.
Possibly, yeah. I mean, so they used to, when they were hiring astronauts back in the past, they used to pick them from test pilots and things. So, and even now they like people who have experience piloting airliners and things like that because it's a similar kind of bit of equipment where it's a big complex thing with loads and loads of subsystems and it's like traveling somewhere really quickly.
So, I missed the beginning, but we talking specifically about just pilots or literally anybody?
Anybody, yeah. If you want to be a passenger, you've got to book a ticket on the.
I think there is something interesting in that point about as a passenger, like travel agents they came out at a time when they were connecting disparate services together, and so they realised that I can be an expert in all of these things, and by connecting it together, I can therefore create a service, and people will pay for that service. Weird now that actually we pay slightly less to go through all the stress of finding the flights and the hotel and everything ourselves.
Yeah, exactly. Yeah.
But I feel like that is somewhat like I don't think governments are going to be quick to like say, don't worry, we'll set up the space licensing authority, whatever it is. It will be a private company that comes in and packages up all of those things together.
I agree, and that's like that was going to be the final point of where
Oh,
I'm coming
sorry.
from. Yeah, I was going to say the person who invents train line in space is going to be very rich.
Yeah, we can invest it.
Yeah, and I imagine so with the system, with what you're talking about how it originally being a travel agent, and now it's just an app that you have to book everything yourself on, and it's the same, a huge amount more stress, but with more of the work being done by you, and it costs the same. I mean, I guess that's more of a capitalism thing, really, than the system. But yeah, it's interesting because, like, I suppose the first thing that would need to happen is you need a lot more providers for space travel. So I mean, at the moment we've got two private ones really, and then I guess there's quite a few like national space agencies, but they're quite picky on who they take. So I mean, the first thing is you need more availability for space travel, and similarly, you need to come a lot cheaper, I guess, because there's not that many people who can even afford it. So there's no business. There's not really any profit in it at the moment because there's no passengers. Well, very few passengers. And then to be honest, the pilot thing is even more of an interesting discussion point because, like, I imagine it would be a continuation of a pilot's license, but specifically for space. Yeah.
There's a commerce angle as well, isn't there? It's like, sorry to throw this in there, but like the first commercial train line was from just here to Liverpool. That was nearly 250 years ago, I think now. And like that whole infrastructure was driven by the fact that actually moving people between these two places will make us money. And not just people goods, but I think it's definitely more about people for us. So I guess it got to a point there. So what is the analog that we can identify? It's basically finding a buttload of lithium in space.
Yeah, pretty much.
Rare earth metals.
That's going to be mined by people.
It's going to be mined by people. But no, we'll send robots.
Yeah.
We'll send robots now. So why would people ever need to go there other than tourism?
Yeah.
The robot thing is also interesting because, like, with freight, I can't imagine much will really change because you can already pay a launch to just take a bunch of shit up into space. I can't imagine that'll change much. Yeah.
Do you know how much the cost is per kilogram or whatever?
It's quite a lot.
So
I don't know exactly how much it is.
Based on that, we can assume how much it would cost to send a human to space as well, right? Commercial.
No, it'd be a lot more because there's a lot more safety involved.
Like safety,
Yeah.
So for mission just came down. What the Indians spent like millions getting their astronauts trained and everything and sent up and down, and that was a lot of sliding points there, long missions. That's the first private
Yeah, I mean the main thing with it is like you've got to also take the fuel because you've got to take all your fuel with you, and the amount of fuel you need is like a logarithmic equation because you need more fuel to lift the fuel up into space as well.
Right.
Yeah, so it's quite expensive.
Tyranny of the rocket
Tyranny of
equation.
the- yeah. So Starship tried to sell this, right? They were trying to do point-to-point travel on the planet, and that was the selling point of
Yeah.
why you'd want, because you go anywhere in 90 minutes was the claim, right? So that could be one reason why a business like that would work, if you can get around all the environmental and sound issues.
Yeah, yeah.
So, but that was, yeah, I don't know what happened with that though. They made a demo with like a CGI rendering, but
Yeah, SpaceX are quite good at that.
yeah.
Say they're going to do it and then not do
Well,
it.
yeah. But the idea sounds cool, right? I can get to Sydney in 90 minutes, right, from
Yeah.
London. It's like, that'd be quite cool.
It did take them. I mean, even with airlines, it took them ages to get to that point. Though, for a while, it would be like, okay, so to get to Sydney, you've got to go from London to Paris, from Paris to China, from China to Sydney, basically, because the planes didn't have the range to do it. I imagine in the middle, you probably see a similar thing with space, where they have to stop some. Yeah, they have to stop the moon, on the moon, or on Mars, or something like that.
Yeah, if you talk about interplanetary.
Yeah.
So the Lunar Gateway, for example, that was why that's been proposed as like the launch point for them every other mission.
There's a company across the road, Orbit Fab, and they're making fuel stations for space. So I imagine they've got visions on actual bigger station, like, I don't know, maybe fuel stations will have like a cafe and stuff like that.
Yeah. I mean, I imagine it as being a bit like Star Trek, where they've got space docks, and it's like being on a boat, basically, but in space.
What's the point of information on that? I was at a space conference last year where they were showing a slide of all the current active space stations that are under development. There's 7 under development right now, so that would house up to 30 people in orbit at any one time, on top of what's going on with the International Space Station.
Yeah, I imagine I imagine at the moment they're all going to be in the same place, but eventually you'll have some. So they're all going to be in like. At the moment, all the space stations have been in Earth orbit, haven't they? Whereas eventually you've got to. They're going to have to figure out a way to put one in lunar orbit and keep it supplied and stuff. And presumably you'd have to have something on the lunar surface so you can get materials from the moon into the space station, basically.
Pretty fabulous,
Yeah.
There's a good YouTube channel to check out with that called Anthrofuturism. He does like Blender renders like how to like basically mine the moon and build like mega trains.
Yeah. Yeah, and for those trains, you'll need the train line, but in space.
Exactly, this is it. We're come full circle.
Exactly, yeah. And on that note, I think that's it for me. I don't really have much else to say.
Really fabulous. Who are you and where can we find you in future?
So, James Frankland. I don't have a website, or I am on LinkedIn and stuff like that. Yeah, that's it.
How do I store these properly?
Yeah.
How do I store these properly?
What?
How do I store these properly?
Oh, just.
Who are you? Where are you coming from? What do you want to talk about? Going on between these two guys on camera.
My name is Ahmed, and I'm from Manchester, and I'm here to talk about space debris and like sustainability in space in general. Now, if I remember from the conversation we had about self-healing materials, I think space debris travels at 30,000 kilometers per hour, right? And obviously, there's a lot in there. I think I can't remember the exact digit. I'm not an expert, by the way. I haven't fact checked any of this, but I think there's about 100 million bits of space debris that are small enough that we can't even track, like flecks of paint, dust, debris, and it's like going at that speed. If it hits any satellite or something, it can just obliterate it, which is very, very bad for our future in space. because every satellite that gets destroyed puts more debris out there. It's exponential growth. So there's a couple solutions. The best solution currently, like sustainability, we don't put as much debris out there, which we're getting better at. We're bringing a lot of stuff back down, but then there's also ways that we can like remove the stuff we already have up there. Like the biggest satellites, I think the solution that I like the best is something called the laser boom, which is on Earth. It's a big laser which heats up and melts part of like a larger structure, which would destabilize orbit and bring it back down to Earth. Or like small debris, it could possibly melt them. Does anyone else have like any other like ideas or anything? Yeah.
So I guess, I mean, my ideas are just what other people are doing at the moment. I guess you've got stuff like Astroscale and Clear Space where they've got like, they have a spacecraft go up and got
Yeah.
a magnet on it, and they shoot the magnet at the debris spacecraft or whatever.
Yeah.
And they pull it back and then they deorbit it.
Yeah, that's a very good solution. It's I think there's also things to consider for that as well. We need to consider how we're also putting craft into space. The thing that we're doing to clean up the debris, we need to make sure that doesn't get like, that doesn't turn into more debris. That's something we need to consider. There's cost considerations, but that's a good idea for like bigger structures.
Yeah, I imagine because it'd be quite limited. It's a meteorite. Meteorite is going to be mostly
Yeah.
mostly like silicon, other stone materials and things like that. So you won't be able to use it for that. And I think they were coming up with a big net at some point as well.
Yeah, definitely.
Another way of doing it.
Definitely, I think like return like launching a craft and then bringing the debris back. That's one of the bigger things. We do really need to consider like sustainability for how we approach space travel. This in particular, this could end up being a real issue. It could set us back a couple of years, which is like very bad. And
Well, I mean, what
Yeah.
somebody here is that works in the field.
Yeah, one of the ideas that I have been looking at is using kind of armor paneling on satellites that are going up that absorbs the debris naturally.
Yeah.
So you could use things like aerogels or ablative shielding, which is what Affiliate Industries does.
Yeah.
Magnets again. But no, I'll do my little talk about what kind of systems.
of course, I like the magnets idea. It's cool. It's also like a non-contact way of like kind of bringing them down or like launching them further out.
But the real change that needs to happen is policy change from government and international standardisation, saying that the way that launches and satellites have been going up is just completely out of control. It needs to be controlled and maintained and regulated, so that we don't have the Kessler syndrome completely wipe out all of our orbits. So
Yeah, definitely. It's probably more important to not make a mess in the first place rather than go back and like frantically clean it up as well.
Yeah.
There's a big issue at the minute with space debris where everything up there technically is owned by the country that launched it.
Yeah.
But nobody wants to pick up their trash. So nobody wants to take responsibility for the stuff that's not there.
Responsibility issue, so that needs to be changed in the standardisation, I suppose.
Yeah.
So it's a legal issue really.
And that's actually one of the biggest things holding back a lot of space debris companies.
Because nobody wants to capture somebody else's.
Exactly. You end up causing an international incident. Nobody wants that.
Yeah.
Yeah.
True.
Definitely. Is there anything anyone would like to add? This is very short, but it was very quick.
So I guess I don't do anything to do with space debris, so shoot me down if you like. But is there any way, people have talked about nets or some kind of fabric, is there any way of using non-Newtonian fabrics, so things that harden on impact, to be able to try and wrap themselves around pieces of debris in space, and then on the impact it hardens and slows down, decelerates it, and then being able to taxi that down into the atmosphere or further out the other way?
Literally never heard that before.
You never heard of like materials that
that's a really smart idea.
Well, no, I've heard of the material. I was never heard of the idea of sending non-Newtonian materials.
I think that the only challenge would be to have enough of it to send up.
That's
It's essentially like engines on all four corners. If you imagine a blanket,
Yeah. Yeah, yeah.
or a net, and then
Hardening net.
it hardens when things hit,
I suppose
and
you
then
could use some kind of
closes up
ridges.
and taxis things a certain way and emits it to the top of the atmosphere. I don't know. I'm just
You could
I'm
have
just
like
freestyling.
you could have like hexagonal panels that in a certain shape would click together, and then just bring it down.
It changes it.
Yeah.
You could have something similar to what you said, something with like 4 engines on it. But what if you could make it really, really adhesive, and it would like catch things, and that like as in it would stick to things.
You would literally never hear that in the
Yeah.
Just use glue.
Manchester University, I think, because they developed, is it graphene?
Yeah.
So I think here, I think I read a paper that they developed a new type of material that works like a fabric, but then it can stop a bullet. And it can stop things that move at it really quickly. It's obviously like space debris moves much quicker than that, has a much bigger impact. So yeah, that's probably not the right material. But along those lines in material science, is there something where you could have waypoints in space where something opens up, captures something, taxes it to the atmosphere, opens up again, and pushes it. I don't know. Just idea.
Cool talking point.
Huh?
It's a cool talking point.
Thank you. It was fun. My name's Ahmed. I'm gonna.
Mike.
It's me. Got my little notebook.
So who are you? Where are you coming from?
I am Joshua Nathan. Where am I coming from? Harrogate in Yorkshire, and I'm a founder for Lightbound. I know quite a lot of the guys across the road. Flo let me know about this, so I'm kind of excited to hear all of your stories and work on some projects with you guys. In terms of what I'm going to talk about, it's kind of using space philosophy to solve problems on Earth and with humanity as a whole. So I had this crazy idea. How do you quantify the value of life mathematically using economics? So I wrote it in a blog post. It was absolutely insane. I had some Russian engineers tell me I'm crazy. I haven't tested all the theories, but I came up with this equation. And some of the findings were quite simple. So NASA has detected 5,926 exoplanets. So those are planets outside of our solar system. And, you know, they say there's estimates that there's billions, hundreds of billions, millions, we don't know. But of those, we've only detected 61 that are potentially habitable with all of our instrumentation and massive amounts of money that we poured in. So, yeah, we tend to get a bit arrogant and think that we know what's going on. We really don't. But still, we've mapped a huge area of space and we've found how many signs of conscious life? 0. So if that's anything for you guys, it's that your life is precious, it's very valuable, it's very rare. So take that with a bit of confidence. But for the other side of it is that we have this climate catastrophe to combat. And funnily enough, if you're designing deep space craft or stations or even robotic systems, you use this closed systems mentality. And a lot of those closed systems designs can be used very quickly on Earth to solve climate catastrophe problems. And that's really what we're doing at Lightbound, looking to bring people together in places like this and solve real world problems, and then build the infrastructure to go further. So there you go. Any questions?
So let's challenge your first point there.
Okay.
So yeah, we've taken so many exoplanets, obviously no life on those. But mathematically, just in our galaxy alone, right, there is life.
Yeah.
So you can't like disregard that, I guess, in your calculations. But I don't disagree. Like we need to look after kind of our planet, and
yeah,
that's the only one that's
I would agree. You know,
how do you bring that?
Our galaxy is massive. We haven't mapped, you know, huge areas of it, so there is a good likelihood that there is life there. But from what we know already, the probability is very, very low. So that still makes our life quite precious and rare. So just going off what we know. I don't know if you've got any mathematics that can help me with my next blog post on the topic. I'd love to hear it.
They use something like the Drake equation, like kind of points that out. But
Yeah.
there's only 60 planets, so it's not that many compared to how many planets are actually out.
Yeah, and that's the thing. And the vastness of space, you'd think it's a lot more. And you're seeing all these conflicts around the world, and it's really quite tragic that we're wasting so much potential. So yeah, the blog post actually writes about other things like ecosystem services, biodiversity, plants, genetic potential in our DNA, all the data that becomes with it, neurological potential, also then knowledge accumulations over time, which could continue if we don't destroy ourselves. So yeah, it's an interesting topic.
Yeah. And then one more. So
Please, yeah.
So you mentioned like using closed systems on Earth.
Mm-hmm.
So have you got any examples of that?
Yeah, yeah, please. Well, I wouldn't tell you exactly everything, but I set up a small team, and we entered this interstellar institution competition to design a generation ship for 250 years. And I thought, it'd be a bit of fun. It was insanely hard work, but the procedures that were put into play were fantastic. And when we were looking at the ELCS, or the life support systems designs, if you map out a simple life support system for a spacecraft, you could then apply that to, say, an estate or a pub or a house or even a city, and very quickly you'll make a very efficient system, given that there's not a lot of people going out polluting stuff and whatever. But that's just one example. Yeah, I mean, it doesn't have to be necessarily fully sealed, but yeah. But if it's designed with everyone's needs in consideration, then it'd be fine. And then you could also have sub-containers that go out that are also closed systems. So there you go. It's an interesting way of thinking.
So is the biggest problem here cost? Is that the only?
For my business set, actually it's personnel. So I'm just the founder running around like a mad fool. I've had several parts of teams come in, but I need a co-founding team essentially before I can really push on. In terms of cost, I've got a few investors and schemes fishing around, but yeah, again, team first, and then all the rest will fall into place. Any other questions?
Yeah, I had two. The first one is about the planets. So you meant, how many planets did you say?
So the latest count that I literally just read up from NASA was, so 5,926 exoplanets. So those are planets outside of our solar system that we can confirm are planets.
So out of those 60,
61 are potentially habitable. So they have like, what was the latest one? It was Kepler 2b/18b. Which had a 3 sigma rating of dimethyl sulfite, which potentially means that it's got some kind of microbes living there. So they use all sorts of instrumental processes to look for these life support signatures, and then they categorize it with this decision matrix to call it a potentially habitable planet. And it's ticking up all the time. I mean, we're getting better instrumentation, we're getting better data processing systems, but yeah, obviously at the moment the odds are very, very slim of what we've got here, basically.
So isn't that a lot then? Like that's nearly 1%, right? So 1% of the exoplanets we've found so far have been inhabitable.
Yeah, but of all the planets in the galaxy and in the area that we've mapped, that's like out of hundreds of millions plus, basically. There's a point.
There's a theory that a lot of.
But even 1% is not that much, is it? Really? I don't know. Sorry.
There's a theory that like a lot of solar systems look similar to what we have here, and then there are gas giants and there are rocky inner planets. But yeah,
it's possible that just the vastness of space is a massive hindrance to us, because we can only flow through very, very slowly, really. But yeah, I have another idea for FTL, but that's much further down the line, probably when I'm dead. Anyway, any more questions?
Yeah. So
Go on.
what you were saying about your blog post then, like what did you come out to? How much does a human life cost?
A lot, basically. Yeah, you can read it if you'd like. But I wrote an equation. Yeah, so if you look up Lightbound on Substack, Or you can see my LinkedIn, Joshua Nathan, on LinkedIn, and you've got a photo of me wearing sunglasses behind a big building in Salzburg. So yeah, I have to go into the UN in Vienna and getting scared. Cool.
We're good. Smashing.
Thanks a lot, guys.
I mean, we're coming to like the end of the official time for open sessions. If anybody has anything they want to talk about.
Can you load one of the picture of the space and solar power? Anyway, can find that.
Space solar power.
Yeah, anyway,
So how are you awake?
anyway, yes. Okay. Any picture. That's great. Okay, so perhaps the topic I want to discuss will be the space-based solar power. So solar power, I think we're all familiar with that. There's plenty of solar panel on the ground, and on Earth there are solar farms. You can see, because I live on the Wirral, so the other side of Liverpool, between Wirral and Wales, there's plenty of solar farms over there. So what is space-based solar power? The idea is not new. In the 1940s, people wrote science fiction saying that actually you can harvest power from the sun and then transmit the power to the earth. So in the 40s, that's a science fiction. But in the 70s, people actually write a science paper. People are taking that more seriously. They write a science paper saying that actually this idea could work. Then NASA has worked on this project, on this idea for many years. So nowadays, many people are working on that. So even 20 years ago, when I heard, about 15 to 20 years ago, when I first heard of this idea, when I sit in a conference like this, I still think that's a science fiction, because it's not just possible for many reasons. One is you don't have that microwave amplifiers, a signal generator in space. And then at that time, the antenna array is in its early stage. You can't develop such a big antenna array. Thirdly, the launching cost will be huge. At that time, launching a satellite will be very expensive. But nowadays, due to SpaceX, due to all other technologies, the launching cost, even compared to that 15 years ago, the cost is about 1%. So then you got all the semiconductors, GaN devices, etc. You can actually generate the high power in space. And also the antenna array has been developed. So now all of a sudden, 15 years in the history is a sudden. So all of a sudden people think this is very feasible. So people are doing that. So the idea is quite simple. Yes, you can have a solar farm on the ground, but how about put them in space? In space, you don't have any weather. You don't have any light time. You can just harvest energy at any time of the day, any time of the year. But that's not accurate. Actually, roughly about 45 days a year, there will be an eclipse. So the satellite will enter the shade of the Earth, so you couldn't harvest that for the full day. Maybe there's 1 or 2 hours off. But other than that, you can have constant power from the sun. Harvest that then down to the Earth. So that's all the good story. But then there are problems. For example, people are worried. Is that safe? Because we're talking about a huge amount of power. So because this power is small, then it's not worth it. So how much power it can be? People are talking about gigawatts. So people are very ambitious. They're talking about from now until 30s, they want to maybe develop a system that can deliver kilowatts, just a prototype. From 30s to 40s, they want to deliver megawatts. So megawatts, put into that perspective for the fusion project, it's a huge one. There's a white paper, you can search that now. Their ambition is that in the 30s, they want to deliver 500 megawatts. But then people are thinking in the 40s, they want to deliver gigawatts. So from 1 to 2 gigawatts up to 10 gigawatts. And once again, put that into perspective. The UK now, the energy demand is somewhere between 40 to 75 gigawatts. Then if you can deliver 10 gigawatts, that's a quarter of UK's LNG demand. That's a very high percentage. So then that's all the good side. then because the power is so high, is it safe? So when you transmit the energy from the space to the Earth, nowadays there's usually two methods. One is laser. Laser can be very focused, energy can be very high. It's very effective, but people have safety concerns because how about any aircraft or any airplanes or any human beings, wildlife underneath? So people use a microwave. So microwave in general is quite safe. So then because this one, they want to put the solar farm in space, you want to harvest more power, you need a big solar farm anyway. So the area is typically several square kilometers. So you need a bigger area to harvest the high power anyway. Then you convert that to microwave, then beam down to Earth. So the power density is quite low. So the power density is comparable to the sun power on the equator. So in other words, it's very safe. And then people are worried about, because for the sunlight, we are exposed to that every day, but not a microwave. But in general, I'm not a medical doctor, but in general, microwave is quite safe. The reason I say that is not from the medical background, it's from the mathematical background, statistically. So if a microwave is dangerous, then in the last 10, 20 years, people using mobile phones, using microwave ovens, using all that, then you will see the skin cancer or brain cancer will be shooting up like that. But we don't see that, which means that relatively microwave is safe. So it is safe, and we are talking about high power. Again, these are the good things and the things are solved. What are the technical challenges? I've mentioned a few. So for example, at the beginning, 15 years ago, you don't have that semiconductor device to generate that micro power. You don't have that antenna array capability to develop such a huge antenna array, and you can't launch them. These problems are gradually solved. But then, as always, the diva is the detail, right? If you look into the details, then things are not that simple. So for example, in a big solar farm like that, there's many small units. How can you fabricate them? How can you make sure that all these small units, they can be developed on the Earth and launched them? Then you can't do that in one go, because several square kilometers, you just can't launch that in one go. So you have to launch that bit by bit. Then it has to be scalable. So you do a little bit, then in space, then can be assembled, maybe using robots. So that is the technical challenge. There are many other things. For example, because it's so huge, if you want to deliver power to the ground, then you have to focus the beam. The beam, you can easily calculate that, because usually these satellites will be in the geo orbits. Then the height is 36,000 kilometers.
What is geo orbit?
Yeah, geo orbit. Because geo orbit, they can always facing the sun.
Just people that don't know about anything through space, what is geo orbit? What is
People starting with the LEO, then eventually it will be GEO, because that antenna array has to be focusing on the Earth's fixed point. If the LEO is orbiting, then you need many of these substations on the ground, which is not quite feasible in the power. So in GEO, always focusing on the same point on the Earth. That's why. So then for that orbit over there, so then it's a big, huge array. How do you synchronize them? Every antenna, they needs to be focusing on forming a beam, focusing on to the Earth. They need to be perfectly synchronized. If you calculate that, then it's a very huge challenge. And also when you gather all the power from down to the Earth, then you need a big solar farm on the ground to actually harvest that. So then that beam, then if you calculate it easily, is 36,000 kilometers above the ground. It's 0.001 degrees. It's just more than a pencil. It's very, very challenging. So all these challenges, but we still need to overcome that. Then it has to be lightweight. It can't be very heavy. It's not talking about one satellite or this unit. Well, I'm just asking the weight, because if you want to launch something several square kilometers, the size, weight is very important. And then previously we discussed space debris. At the moment, the space debris is mainly a problem on the LEO, on the lower Earth orbit. But if you want to launch something in GEO of that big scale, then it can be a huge problem, because then it's so big, so it's easily be hit by something. But if that one is...
My question with it is, like, is there like a hard limit on how big we can build things before space debris becomes too big a problem for it?
I think there's a syndrome we were talking about. So to a degree that the Earth is actually be covered by space debris, no one can launch anything to live in the Earth. So people are talking about that. Yeah. Yeah, we're also, so maybe in the next space conference we can talk about space debris, because this one can be a problem, but can be a solution as well. But we can talk about later on, so in terms of space debris. So you can see that there's plenty of challenges that needs to be overcome. But then there's great future. For example, if these satellites can be launched to Earth, it can provide maybe, as I said, a quarter of the UK's energy demand just for one of them. You can have multiple of them. Then you can deliver the power to different places. And then we're talking about the Martian, talking about the moon. Then actually you can use the same idea to deliver the power to the moon, to Mars. So in Mars, how do you get the power? You have many robots over there, many trucks over there, manufacturers over there. How do you get the power? This can be one of the solutions. So then you also have the power transfer. So you have the power, then you don't want to run too many cables so that they can deliver the power, or run back to the base for charging and then going back. Then if you can actually deliver the power to the devices or the equipment, the vehicles directly, that will be useful. So you can see that this is a one idea, one project, which can bring many other benefits. In other, for example, in nuclear weapon, in nuclear sites or some other fusion sites, then if you can wireless power transfer using the same technology, you can provide the power over there. So in terms of the ambitious, I think many countries in the world at the moment, they're developing technology for this. So people are very optimistic. It is feasible, but there are many challenges to overcome. So that is what I want to say. This is there's no operating system just yet, but people think it might be the case in next 10 to 20 years. So we're developing quite a few things on that, and then if you are interested, then more than welcome to discuss, and hopefully you can develop something.
And just what's your background for everybody else?
Yeah, so I'm Javan Zhou from the University of Liverpool. So my main background is on the wireless communications, wireless power transfer, and especially using radio waves, electromagnetic waves. So for us, the information and energy is the same thing, because you want to transmit the radio waves and receiving radio waves. And you can either use that for information transmission, or you can use that for power transfer. So we are using radio waves for the wireless power transfer and communications. We also do wireless charging. For example, we have phones, we have drones, then we can develop all different prototypes to charge your phone, charge your mobile phone, charge your drones, and things like that.
Domain level expertise, thank you so much.
Thank you, thank you.
Have you any questions?
Yeah. Okay. So you're saying that using microwave to transmit isn't dangerous. So I played SimCity. I remember the disasters where microwaves could destroy whole cities. But you mentioned so there's gigawatts of power being transmitted onto like the size of a pencil. Is that?
It's just several square kilometers.
Oh, so
and the ground, it's also
receivers.
So that's a little bit more technical than that. So that antenna, both on the space and on the ground, they have to be big for a number of the reasons. One is in space, it has to be big because it needs to harvest sufficient power. And then if you want to form a very narrow beam, you need a big antenna. It's not dish, but imagine if it is a dish, then you need a big dish to form a very narrow beam. So you need that. And a third reason is now it can lower down the power density. So power is high, but power density is quite low. That's quite safe.
So you're narrowing the beam down, and then the receiver.
Yes. The receiver is very big. It's still several kilometers, square kilometers.
Okay.
Then the power.
Yeah. What point does it then spread out to be collected by?
You have to be spread out for a number of reasons. One is health and safety. Another one, you have to have a high gain antenna, because antenna is a two-way thing. You can still imagine the receiver as a transmitter, because it's just a two-way thing.
Okay.
Yeah, so reciprocal thing. Then if you want to receive that energy from that particular direction, it needs to be big anyway. And adding to that, if you have two antennas far away from each other, their transmission efficiency will be very low. You have to make them physically close. So then when you have antenna arrays, you can work out what is the frequency, what is the dimension, to make sure that they are actually what we call the near field. You have to make sure this antenna array is big enough, make sure these two antennas is in near field. If not, then efficiency will be dropped exponentially. But if it's near field, the transmission efficiency can be up to 90 or 100% in theory.
I think I need to see some diagrams.
Yeah, yeah.
So you mentioned that you can use radio frequencies for power or for data.
Yes.
Would it be possible, just hypothetically, to communicate both data and power from one piece of hardware in space to one collection of antennas in one unit on Earth? Could you do both in parallel, or does it have to be separate or one or the other?
It can be perfectly done simultaneously. So actually, in our research, we do. It's called a term for that. It's a SWIFT, simultaneous information and energy power transfer. So it's a term for that. We do that. But just in this case, the power is huge, and the actual signal power needed for the communication is very, very tiny. So then we separate them. But in hardware, there's nothing preventing to do the same in one link. So it's perfectly possible.
One piece of hardware
Yeah.
where you could receive a power stream and you could also receive a data stream. It would be two different receivers in the same unit, maybe.
It could be, but once again, I can talk you in more detail about that. For example, there's a pilot signal. So how can you make sure they're two perfectly aligned? So at the beginning, they would have a pilot signal. So the status or the communication, they will be using that link. And then so for us, we also develop some other wireless power transfer technology. So we have to make sure if that direction is correct. So we have to establish the communication first. And if it's fully charged, you have to switch off these things. So the communication and the power transfer is actually the same system. But then we use protocols to make sure that they will not interfere with each other.
Cool. And will I be able to get your card later?
Yeah, I'll do. Yeah, sure.
Yeah, of course, because we've been meeting up at the Northwest Space Cluster.
A couple of times,
A
yeah.
few times,
Yeah.
So we've spoken about wireless charging before, but obviously, I mean, this is you're in the Northeast as well, so.
Yeah.
I know someone who's who's creating antennas for cars. Essentially, involves one unit that fits inside the roof. So not having like the shark fin, for example, or co-locating antennas from around the car, so data can be. So cars can always have connectivity. But I'm also thinking like how that then applies if you were looking at cars, chargeable, EVs and things like that. So would it be possible to charge a car with satellite-based power and also be able to give it its connectivity? So sounds wild, but this is a company that's now raising a £5 million round. So they're in business and they've got an academic who's developed the first antenna piece that's been put into luxury cars with BMW at the minute. So I think that this would be interesting. I just don't know if it's feasible. It's just someone I know, so I was like, maybe this is a good introduction to make. So.
Absolutely, I should know you earlier then. But then, yeah, we are more than kind of happy or more than capable of developing all these technologies. We can develop antennas, circulators, amplifiers, filters, whatever is needed. And also, just one point to add is that in the normal environment, we can do the wireless charging. For example, we can charge your phone using microwave easily. The reason we don't do that is not because of the technical one, it's because of the health and the safety. Because otherwise, it can just radiate to people, then it's not. So technical wise, it's perfectly possible and feasible.
Sorry for the
Yeah. No.
There's the last question. The pub quiz is starting at 6.
Okay.
It's now 5:15, so
Okay.
it gives us about half an hour for a comfort break.
James, final question, please. Yeah.
So I was at a conference in Bristol a few years ago where they were talking about, I think it's run by Space Solar, and they were talking about this kind of stuff. That's the company that sell satellite applications catapult to start Economist. I think it's still around.
Yeah.
One of the problems, one of the issues they highlighted was where are they going to put the receiving antennas? Because their choices were essentially places where there's loads and loads and loads of spaces. It was absolutely massive at that point in time. So their choices were something like Norfolk or in the sea or in Scotland basically, or in another country close to the equator where they would get more, where the gain would be a bit better. I think that's an interesting.
I think, in my point of view, I think that's an easier problem to solve. The reason is, on the ground, you have many solar farms already. You can have a dual use. People are talking about that. So on the existing solar farm, in addition to the solar panel, you can put the direct antenna array on top maybe it's transparent one. So land is no problem. Power density is no problem. Interference might be, but if you control the beam, control the power, the side lobes. So again, if you talk into the detail, then things are quite complicated because this is a beam, the side lobes over there. How do you control them? So that might be issue. But in terms of the land, it just wouldn't be much bigger than existing solar farm. Yeah. So it should be fine, and you don't have to avoid anything because the power density is quite low.
I see. Thank you.
Yeah.
Really smashing. Thank you so much.
Thank you.